So here we are to look at the principal reversibility of light. It may look like familiar because we had already looked at it in reflection, but here we are to look at the reversibility in a refraction. We can also still state it as before that. It states that light rays, that if light rays is reversed, it follows the same path. Okay? That if we reverse the direction of light, if it was moving from the other side, like as we're going to see that if light is traveling from this side to this side in this direction, if you reverse it to begin this side, it will also still follow the same path. That is what we are calling the principal reversibility of light, that light can reverse its path. It can move from the other point to this side, and from this side to the other point following the same path. That is what we are calling the principal reversibility of light. And now let's look at the relationship between refractive indices. I'll say consider a light ray or from glass refracted as OB in air as shown below. Okay? That supposing I would say maybe, let me get here some better pen here. I can say if I have that, I have this. This is my air that I'm talking about, and this is my glass. Okay? Let me try drawing something better. So if this is my air and this is my glass, so if this is normal, this is point O, I have this, we say it will be refracted away from normal. This is the refracted one. Or I cannot name it because I will reverse. This is maybe angle X. This is maybe say angle Y. Is that okay? That is my angle Y. This is glass, this is air. And then we are looking at it O, AO, let's call it here AO, and then OB. Isn't it? B is here. So it is from glass as O, AO, and then refracted as OB. So we can now say the refractive index of glass to air is given by, now that light rays is moving from glass to air, so the refractive index of glass with respect to air is equivalent to the sine of angle here over the sine of angle in glass. Okay? And now we can say, by the principle of reversibility, of light, if the path is changed from air to glass, then the refractive index of air to glass is given by, will be given by now air to glass will be equal. Now supposing our ray is now moving from air to now glass, we shall say from air to glass we now begin with air up, which will be sine y out of sine x. Okay, this is equation 2. And now we can say equation 1 times equation 2. What are we going to get? We are going to say G NA equaling to sine, G NA times A NG is equaling to sine x out of sine y times sine y out of sine x. You realize that this is going to be 1, and you'll say G NA times A NG equaling to 1. And then it is true that G NA is equaling to 1 out of A NG. Okay? And from here, we can actually conclude that, so if we are looking at that, it means that from this one here we can say that from glass to air, if I know the refractive index of glass to air, and now I want from air to glass, it is just the reciprocal of the refractive index. So we say if light travels, I can say similarly, if light travels from medium 1 to medium 2, then the refractive index of 1 to 2 can be related to 2 to 1 by saying that we are saying that now supposing the media is supposing light rays is moving from media 1 to 2. Now we want to get 2 to 1 from that. What we can say is that 1 to 2 moving from media 1 to 2, the refractive index is the same as 1 out of 2 to 1. Okay? It is the same as the refractive index of 2 to 1. Okay? So, an example here is that if the refractive index of air to glass is maybe 1.52, and then find the refractive index of glass to air. Okay? So We are saying that if at all we have that refractive index of air to glass is 1.52. What about from glass to air? We say this will be reciprocal of the other one. Now that will be equal to air to glass, and that is 1 out of 1.52. You can now tell us what actually transpire in such a calculation. Can we now have our calculator around here if it is there? But in any case, this can be easily pressed, okay? So you can just say 1 divided by 1.5 that, and you'll get a value which is maybe say 0 point something something. So let me use this calculator here now that I have it. So I can say 1 divided by 1.52, and that is giving us 0.6 something something. So this is giving us 0.65789, and you can see it is 0.658, and that is now if the light is now moving in a different direction. So you can try for air to another media, and then from that media to air, number of them, maybe to water being 4 out of 3b, look at another one maybe 3 out of 2, number of things, and then look at what comes out. But all in all, note that if we have refractive index of one media to another one, if we reverse it, it will now be the reciprocal of the first value. So that is very, very important.